Hi everyone, this is Sugantha Priya, Assistant Professor, Department of Computer Science, Dr. SNS Rajalakshmi College of Arts and Science. This presentation is about scheduling concept in the subject operating system. So let us discuss about this topic. So before entering the topic, so what do you mean by scheduling? So the process scheduling is generally an activity of a process manager that is going to handle the running process of the CPU, and it is going to select the process based upon the several strategy. Generally in a multi-programming environment, so multiple processes are executed simultaneously, and this multiple process is going to compete for the CPU at the same time. So compete in the sense, so it is going to utilize the CPU to its maximum. So when two or more processes are being simultaneously executed in an operating system that is in a ready state, so the choice has to be made by the operating system, that is which process to be run next. So this part of the operating system, generally it is called as a scheduler, and we are going to use the algorithm to schedule the processes. So next we will discuss about several scheduling criteria. So the scheduling criteria is based upon the CPU utilization, that is the CPU should be utilized to the maximum. Next is the throughput, turnaround time, waiting time and response time. So there are two types of scheduling generally. One is preemptive scheduling and second one is non-preemptive scheduling. A preemptive scheduling algorithm is going to pick a process and it is going to run to the maximum amount of some fixed time. So the fixed time is fixed by the operating system, so based upon the type of the process. So next type is a non-preemptive scheduling. In the non-preemptive scheduling, the algorithm is going to pick a process to run it, then it run until it blocks. So either on an input output or an waiting for another process, or until it is going to voluntarily releases the CPU. So in the preemptive scheduling, if a process is assigned to a CPU, it cannot be taken back until it is going to complete its execution. So whereas in the non-preemptive type, so the number of times the process is executed in the CPU, it can be taken n number of times whenever needed. So next we will discuss about the different algorithms used in the batch systems. First is an FCFS, next is the shortest job first, third is the shortest remaining time next. So next is an example for an FCFS. FCFS stands for first come first serve basis. So here we have four different processes, so with different arrival time and service time. So using an FCFS algorithm, we are going to execute this four different processes. So the process that has arrived first is the first to be executed. So in this example, process 1 has arrived first. So now it is executed first from 0 to 8. So next second process is executed from 8 to 12. The service time it is 4. So 8 plus 4 it is 12. So next process 3 is executed with the service time of 9. So already P1 and P2 is executed. So now P3 has to be executed with the service time of 9. So 12 plus 9 it is 21. So next fourth process to be executed is your process 4 with the service time of 5. So 21 plus 5 it is 26. So now all the four processes are executed in the CPU. So next we have to find the average waiting time. So the average waiting time, it is service time minus arrival time. So if service time for process 1 it is 8, 8 minus 0. So next for P2 it is 12 minus 1. For P3 it is 21 minus 2. For P3 it is 26 minus 3. So the total is 61. So divided by number of process it is 4. So the average waiting time of the process is 15.25 in the FCFS method. So next we will discuss about the shortest job first. So this type of algorithm is a non-preemptive scheduling algorithm. So this is the best approach to minimize the waiting time. So here shortest jobs are first given higher priority. So we get the response time in a more better manner, and also it is very easy to implement in the batch systems where we know the CPU time in advance. So this type of systems cannot be implemented in interactive systems because the time execution of the process is not known to the user. So this is an example for the shortest job first algorithm. Here we have four different processes. So starting from P0, P1, P2 and P3. So we have arrival time, execution time and service time. So the process with the shortest job will be executed first. So P1, P1 So P0, P3 and P4. So P1 is the shortest job, so with the service time of 0, so that is executed first. So next process P0 is executed, so the service time for executing this process it is 3. So 3 plus, so the execution time it is 5, 3 plus 5 it is 8. So next shortest job is your so P3, so with the service time of 8. So already P0 is executed until 8. So 8 plus 8 it is 16. So next shortest job is your P2 with the service time of 16. So that is executed next. So next we have to find the waiting time of the process. So for P0 it is 3 minus 0, it is 3. For P1 it is 0 minus 0. For P2 it is 16 minus 2, which is equal to 14. For P3 it is 8 minus 3, which is equal to 5. So the average waiting time for the shortest job first algorithm is 5.50. So the main advantage of this shortest job first algorithm is the shortest jobs are executed in a more faster manner. So next we will discuss about shortest remaining time next. So it is a preemptive version of the SJN algorithm. So here every process is allocated a job that is closest to the completion. So it can also be preempted by a newly ready job with the next shortest time to complete. So this is impossible to implement in the interactive systems where the CPU execution time is not given. So mainly this type of algorithm is used only in the batch environment. So where shortest jobs are given more preference in this type. So next is scheduling in interactive systems. So in the scheduling in interactive systems we will discuss about round robin scheduling. So round robin scheduling is a preemptive process scheduling algorithm. So here each process is given a fixed time to execute. We tell it as a quantum. So every process is executed based upon this quantum. So we will see an example for this. Here the time quantum it is fixed for it is 3. So here every process so is given a time quantum of 3 to execute. So here we have the different process P0, P1, P2 and P3. So every process is given an equal importance of a time quantum 3. So the average waiting time is calculated as, so waiting time is calculated as service time minus your arrival time. So for process P0 the arrival waiting time it is 9. For P1 it is 2, for P2 it is 12 and for P3 it is 11. So the average waiting time from the round robin scheduling it is 8.5. So next is priority scheduling. In the priority scheduling it is a non-preemptive algorithm which is used in batch systems. So every process is given a priority. So based upon the priority, so the jobs are executed. So the process with the same priority is first executed and the process with the same priority is executed on the FCFS basis. So we will see an example for this. So here we have a different process P0, P1, P2 and P3. So we have arrival time, execution time and the priority and the service time. So based upon the priority, so the jobs are executed. So the job with the highest priority is executed first, so followed by the next priority and so on. So we have to find the average waiting time for this priority scheduling. So P0, P1, P2 and P3. So for P0 it is service time minus arrival time 9 minus 0 which is equal to 9. For P3 6 minus 1 which is equal to 5. For P2 it is 14 minus 2 which is equal to 3, 12. P3 which is 0 minus 0. So the average waiting time it is 6.5 using this algorithm. So next is a multi-level queue scheduling algorithm. So in the multi-level queue scheduling algorithm, so the jobs are prioritized based from lowest priority to the highest priority. So here we have a lowest priority batch process, so followed by the batch process, interactive editing process and the interactive process and the system process. So these are the runnable process in an operating system. So based upon the priority, the jobs are executed one by one. So here we maintain a multi-level queue. So based upon the priority, the jobs are executed. Thank you.